Welcome, Mindsetters, to this session of Learn Extra Live. We're doing grade 10 maths. And not, Natasha, what are we going to be doing today?
Today, grade 10s, we're going to be looking at geometry revision. So that's a whole lot of work to do. If you've been following over the last few weeks, it's really going to be a jam-packed session. So I suggest that they get questions in, Ty.
All right. I think so too. So while Natasha makes her way to the board there, you guys know the drill. Hit me up on www.facebook.com/learnextra. And guys, you know the drill. You know the drill. We have to give these away. So guys, I want you guys to keep posting on the page. Post, help out, everything you can do to win one of these. Make sure you guys are talking to each other on the page, because you guys, the page is for you. It's supposed to help you guys. And make sure you have your pens, pads out, and you guys are making notes. It's so important. But for now, I just want to send a quick shout out to Liberty and say thank you for sponsoring. And I'm actually going to hand it over to Natasha, who's going to take it away.
Thank you so much, Ty, and thanks for joining us, grade 10s. Great to have you along. Today we're looking at geometry revision. And as you can see on the screen already, I've got something called a fun diagram. So hopefully today is going to be lots and lots of fun with geometry. So what is the fun diagram all about? I'm going to get stuck straight into the lesson because we've got so much to cover. The fun diagram really tells you what happens and what types of angles you get when you have parallel lines cutting a transversal. So the first type of angles that we look at are called corresponding angles, and corresponding angles usually give you this F type of shape. So what you'll have is angles on the same side of the parallel lines. You can see they're both on the interior side of those parallel lines, and if you get this kind of an F shape and those two lines are parallel, then we say that the angles, or the corresponding angles, are equal. All right. The next shape that we get when we get parallel lines cutting a transversal is we get co-interior angles. Co-interior, what does that mean? Well, obviously they are interior to each other. So if you look at these two, X and Y, all right, they sort of formed on the interior sides of those parallel lines. And we sometimes, this is a U shape, but it sometimes can be in a C shape. All right, so anything that sort of looks like a U or a C will give you co-interior angles if the lines are parallel, and those angles are supplementary. Remember, supplementary is just a big word to say that they add up to 180 degrees. So when you get co-interior angles X and Y, if you add them together, you would have them equaling 180 degrees. All right, that's all that supplementary means. Then the next special type we get is alternate angles, and that's, if you look at sort of an N type of shape, if we look at our diagram, so we've got them on either side of the transversal. All right, those are called alternate angles, and those alternate angles are equal. In my diagram, it looks like an N, just so that we can make the word fun, but you can also get them on the Z shape. All right, so the types of shapes you will be looking at to identify your alternate angles is either the N shape or the Z shape. Just very important. Obviously, you only get these angles forming if you have parallel lines. Okay, that's very important. No parallel lines, that means none of these special angles. All right, on the other side of this, just looking at the converse of this, if you have two lines are intersected by a transversal such that the corresponding angles are equal. So in other words, you can see that you have this F shape and those angles are definitely equal. Or the alternate interior angles are equal. So if we look at the N or the Z shape, those are equal. Or if the co-interior angles are supplementary, so what we showed you before, if they add up to 180 degrees, if any of this happens, then the two lines are said to be parallel. So that's sort of working on the converse of what we already know. Okay, so if you get two lines that are intersected by a transversal and you see that you have these features of either corresponding alternate or co-interior angles, then those lines are parallel. All right, guys, as I said, this is really just a revision of everything you've done so far in the term, and obviously we're preparing you for exams. So we're going to go through all of the revision really quickly, lots of theory. We're going to try and get that out of the way before we look at examples. Okay. The next important section that you guys learned in geometry was congruency. Now you'll remember congruency is really just another way to say that one triangle fits exactly over the other. So they're sort of replicas of each other. And what this means is that the triangles have equal corresponding angles and sides. All right. Now, whether to determine whether two triangles are actually congruent, you don't have to show that every single angle and every single side is equal. That's not how you do it. Remember, there's special cases in congruency to show whether two triangles are congruent. Those special cases, let's have a look at them quickly. All right, the first one, right angle, hypotenuse, side. So if we look at the diagram, right, we've got triangle ABC and triangle DEF. If the hypotenuse, which is this side AC, is equal to the hypotenuse of DF, and then we have two corresponding sides, so I just want to get a darker color here, so let's try that again. There we go. And we have side BC equaling EF. All right. So the hypotenuse AC is equal to hypotenuse DF. Side BC is equal to side EF. And you have a 90-degree opposite your hypotenuse, obviously. Then those two triangles will be congruent. And your reason for congruency will be RHS. Right angle, hypotenuse, side. All right. So what that means is you can basically slide these triangles on top of each other and they will be exactly the same. All right? The order of your triangles, guys, in all of this, the order is very, very important. So if we look at the first one here, we're going triangle A, B, C. All right? So we went from A to the 90-degree and then we went to the common side. You've got to do the same thing with triangle DEF. You see we went from D to the 90-degree and then to the common side. You'll see what I mean as we do examples, but the order of naming the sides is really, really very important. Okay, if you get the order wrong, you will lose a mark at the end if you say it in the wrong way. All right, the next reason for congruency, side, side, side. This one really, really easy. We just have that each of the corresponding sides are equal to each other, and if the corresponding sides are equal to each other, then we say the triangles are congruent because of side, side, side. All right, remember I said corresponding sides. So if you look at this diagram, you see I've got one little line here on PQ, and then I've got that same little line on ST. If, however, that line, that single line to show that the sides were equal, was not on ST and say it was on side SU, that would not be corresponding sides. All right, so corresponding sides means that they lie in exactly the same position. So if PQ was not equal to ST but rather equal to SU, those would not be corresponding sides and you couldn't say that your sides were equal. All right, so you've got to be careful that you've got to use the corresponding sides. Okay, the next reason, we've got if one triangle has if two triangles you have the same corresponding sides, two corresponding sides that are equal, and the included angle is equal to each other, then those triangles are congruent because of side, angle, side. So you've got the corresponding sides, two corresponding sides are equal, and the included angle is equal. Important, the angle that we're talking about has to be between the two equal sides. All right, so it can't be, for example, angle G and angle J. Then that would not be your reason side, angle, side. Okay, then those two triangles would not be congruent. So just be careful of that. With side, angle, side, your angle has to be included. And then the last reason for congruency, so there's four cases. The last one is angle, angle, side. So if you get one side and two angles of these two triangles are equal, then the triangles are congruent, and you say your reason, side, angle, side. All right, so you've got two angles equal, one side, then that's your final reason. So our four reasons for congruency, very quickly: right angle, hypotenuse, side, 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 angle, side, making sure that the angle is actually included between the equal sides, and then finally angle, angle, side. We're going to briefly touch on similarity. Okay, there's only really two cases that you need to worry about when you're looking at similarity. So what I'm going to show you here is that two triangles are similar if one triangle is a scaled version of the other. So what that means, if we look at what I've drawn here, we've got this triangle, the first one here, let's call this triangle A, and triangle B. They're basically identical to each other. They're exactly the same shape. The only difference is that B is slightly smaller than triangle A. So that means B is a scaled down version of triangle A. So it's smaller than triangle A, but it really is exactly the same. So they're sort of just a scale down. They're similar, okay? So it's not the same as congruency. These are similar. These are not exactly the same, but they're similar, okay? So what this means is that their corresponding angles are equal in measure, and also that the ratio of their corresponding sides are in proportion. Okay, so with similarity, that's an important thing. Your one side over the same side, another side in the triangle, if those two triangles are similar, will be in the same proportion as the corresponding sides of your second triangle. All right, so they have the same shape but different scales. There's really only two cases we use here. All the angles are the same, so angle, 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 or side, side, side. That's the only two ways that you can prove that something is similar. And really, when you're proving the side, 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 you're using the ratio and the proportion. Okay, so they're not going to have the same measurements, but they're just going to be in the same proportion. So for example, if I look at my triangles again, this could be 4 units, and that could be 8, and then maybe this is 2 units, and that's 4 units, all right? But if I look at the ratio of this side over that side, it's going to be 4 over 8, which is a half. And then if I look at the ratio of the same corresponding sides in triangle B, I'll get 2 over 4, which is a half. Okay, so you see the measurements are different, but the ratios are exactly the same. That's what we mean by side, side, side. Okay, so they're not equal in sizes, in measurement, they're just equal in proportion when you talk about the sides. All right, guys, and as I said, a lot to go through. So far we looked at parallel lines, just reminding you about co-interior corresponding alternate angles. We looked at congruency and similarity. The next thing we're going to look at is all of the different types of quadrilaterals. So I'm just going to highlight a few of the properties, all right? And it's really stuff that you do need to know off by heart, because if you get asked questions on these, it's not going to be on a formula sheet. You need to know it in your head, all right? So a quadrilateral, remember, is just a closed shape, which is consists of 4 straight lines that are basically bound or closed. All right, and there's special types of quadrilaterals that we looked at so far in geometry. We looked at a parallelogram. All right, and remember, parallelogram had all of these special properties. It was a quadrilateral with both pairs of opposite sides parallel. All right, also in a parallelogram, both pairs of opposite sides were equal in length, all right? Both pairs of opposite angles were equal, and the diagonals bisected each other. All right, so with a parallelogram, those are some of the properties that were really special, and we looked at each of those, and we proved also in previous lessons that if those properties held, then the quadrilateral was a parallelogram, all right? The next special type of parallelogram we looked at was a rectangle. All right, so a rectangle was a palm. Palm is the shortened version of parallelogram. It had all 4 angles equal to 90 degrees. Both pairs of opposite sides are parallel, so just remember it's going to keep the same properties as your palm, because a rectangle is a palm. And remember, palm is just short for parallelogram. So it's going to keep all the same properties, that the opposite sides are parallel and the opposite sides are equal. Those still hold, all right? So both pairs of opposite sides are parallel, both pairs of opposite sides are equal. The diagonals bisect each other, but a special property of a rectangle is that the diagonals are also equal in length. All right, so that doesn't happen in every single palm. It only happens in a rectangle where the diagonals are equal in length. Okay, or one of the cases is in a rectangle where the diagonals are equal in length. And we already said that the interior angles are equal to 90 degrees. All right, so those are the special properties of a rectangle. Let's move on to a rhombus. So a rhombus is a special type of palm that has all four sides equal in length. So some of you will be saying, but hang on, that's the same thing as a square. It's not. Okay, and the reason that a rhombus is not the same as a square is because remember, a square, all your angles has to be at 90 degrees. We're going to get to that in a little bit. But in a rhombus, those angles, those opposite angles or those interior angles, they don't all have to be 90 degrees. So it can sort of sometimes look like a bit of a diamond shape or something like that. But it's not, all the interior angles are not 90, so it's not all straight perpendicular to each other. Okay, so it's not the same as a square. So a rhombus is a palm that has all four sides equal, and just like in a palm, both pairs of opposite sides are parallel, and we already said all are equal in length, and both pairs of opposite angles are equal. This is a special property of a rhombus. The diagonals bisect each other at 90 degrees, and they also bisect the opposite angles. So your diagonals in a rhombus, not only do they bisect each other at 90 degrees, but they also bisect your opposite angles or your interior angles. All right. And I think we've covered everything on a rhombus. The next thing we're going to look at is a square. All right. And a square is really just a special case of a rhombus. Okay. The special thing about it is that, as I was saying before, all four interior angles are equal to 90. So if we have a look at, and my drawing freehand is really not that great, but if you have a look at a square, okay, you have all of these angles are equal to 90 degrees. Now with a rhombus, it's sort of a little bit more squiffed. So you're going to have, and I'm going to try as best as possible to draw this, but there we go. Those angles are not really supposed to be at 90 degrees. If it is at 90 degrees, these interior angles, then it becomes a square. Okay, so a square is really just a special rhombus that has all four angles equal to 90 degrees. And we all know that in a square, I think you learned this in baby school, in a square, your opposites, all your sides are equal. All right? Also, both pairs of opposite sides are parallel. The diagonals bisect each other at 90, just as they do in a rhombus. The diagonals are equal in length, and the diagonals bisect the interior opposite angles. So it's, you see, it's got very similar properties to a rhombus. It still has all those properties of bisecting, the diagonals bisect at 90 degrees, they bisect the opposite angles and all of that. The only real special thing is that all of those interior angles are 90 degrees. Okay, so a square is really a rhombus, but a special case. Okay, just remember that. And we've just got two more to look at. A trapezium. This is a quadrilateral with only one pair of opposite sides parallel. Okay, so again, I'm going to attempt a drawing, even though my freehand is not that great, but it looks something like that. There we go. And you just have a trapezium with only one pair of opposite sides parallel. These sides here will not be parallel. All right? And a kite, everyone sort of think about your childhood memories flying a kite. You know what a kite looks like? That's exactly what we're talking about. A kite is a quadrilateral with two pairs of adjacent sides equal. All right, what the other special things is that one pair of opposite angles and only one pair. Okay, this is the special thing that differentiates it from all the other palms and rectangles and all of that. Only one pair of opposite angles are equal. And that's generally the angles between the unequal sides. All right. The diagonal between the equal sides bisects the other diagonal, and the diagonal also bisects the interior angles. Okay. And final thing is that the diagonals intersect each other at 90 degrees. So once again, if I try and draw a kite, okay, that's not too shabby. We have a look at something like that.
Your drawing is not that bad, as long as you can see what it is.
It sort of looks like a kite. Take my word for it, it's a kite. So we say that the diagonal between the equal sides bisects the interior angle. So for example, if these were equal sides, then that diagonal there, that I'm sort of darkening, that would bisect those interior angles. All right, guys. So we quickly went over quite a lot of geometry revision, just getting you back to terms with all of that terminology and, you know, all of that theory stuff that you have to know to be able to do geometry. So I hope that you all followed that. And remember, this is something that's very important in geometry. You learn your theory before you can do any application. So go over your theory well, and when we come back, we'll have a look at some questions, Ty.
All right. So guys, make sure you do whatever you have to do during this break. Go to the bathroom, get snacks, whatever you need to do so you don't have to get up again or fidget or move or do anything, because you know this is very, very important. And guys, I know a lot of people are writing right now, so this is so vital that you stay tuned. But for now, we're going to see you after this break. Welcome back, Mindsetters. I hope you had a nice little break. Guys, by the way, make sure you keep posting on the page. I understand that you guys are posting and you're like, yeah, we understand. But guys, if you parts that you don't understand, make sure you post on the page, help each other out, chat to each other. I'm seeing there's a couple of people out there who are asking, help guys. So guys, don't be afraid to help them as well. Because guys, you stand a chance to win a calculator from Casio and this labeler. So guys, make sure you keep posting. I cannot stress it enough. But for now, guys, I'm going to hand over to Natasha, who's going to continue.
All right, guys, so we're going to carry on with a few questions, but just in terms of the types of questions you should be posting to Ty, I know that it's quite difficult to post, for example, a big diagram. So maybe if you have some theory questions, or if you don't understand where I get my answers from or that kind of thing, please stop us immediately. So that's the kind of thing we're looking for. All right, so we're going to get straight into the first question, which says find the value of x in this figure. And in this figure, what you'll see is that they tell you that AB is parallel to DC. How do they tell us that? By indicating these little arrows. So those means that these lines are parallel. Okay, remember when you get parallel lines, like I showed you at the beginning of the lesson, you should be looking for these special fun angles, your corresponding co-interior and alternate angles. Okay, so let's have a look at how we do this question. So we know that we're looking for the value of x, all right? We see that we are given that this angle is x minus 20, and then this little one here is x. So we somehow need to form some sort of equation, because remember, if you're looking for x, you need to solve for x. It means you need to get an equation. So where do we get our equation from? We know that this angle, and it doesn't have any label, so I'm going to call it y1. All right, so let's call that y1, and let's call this one y2. We know that y1 is equal to y2, so angle y1 is equal to y2. And remember, in geometry, if you make a statement, you need to give a reason. And the reason those are equal is because they are vertically opposite angles. So those are vertically opposite angles, therefore they are equal. So what that means is that if y1 is x minus 20, then y2 will also be x minus 20. But you might be saying, well, why do we want to show that y2 is equal to x minus 20? Because remember, we're working towards an equation. So ultimately, we want to get all those x's in the same diagram so that we can somehow make an equation out of it. Okay, so if we get y2, then you'll agree in triangle XZY, we have all of the little angles, and we can use the sum of the angles of a triangle to help us solve. All right, so what am I saying? If y1 is equal to x minus 20, this means that y2 is also going to be x minus 20. All right, so therefore in triangle XZY, we can say that x plus 60, okay, so I'm saying this x plus this angle 60 plus angle y2, which is x minus 20, the sum of those angles is 180 degrees. And why is that? Because that's the sum of the angles of a triangle. So sum of angles of triangle. All right. Okay, guys. So that would be your reason that sum of angles of triangle. So x plus 60 plus x minus 120 is equal to 180. And we're just going to try and solve that. All right. So I'm going to get x plus x. Remember, it's just an equation now. So x plus x will give me 2x. 60 minus 20 will give me plus 40. And that's equal to 180. Remember, we're just looking for x. So I take the 40 over to the other side. So I'm going to get 2x. Subtracting the 40 from both sides is equal to 140. And then divide both sides by the 2. All right, so we're going to divide both sides by 2. And we'll get that x is equal to 140 divided by 2, which is 70. All right, so it looks a little bit daunting when you see it right at the beginning and the x minus 20 is in it, and it looks all confusing, but it actually works out to be quite a simple question, right? Now we've got x is equal to 70. That is our answer, but guys, you can always go back and check, all right? So remember, the sum of the angles of a triangle is 180. So if I've got x is 70, so that means this angle here in the triangle is 70 degrees, all right? We know that that one is 60, and we know that y2 is x minus 20. And remember, 70 minus 20, because I substitute x as 70, will give me 50. So that means that y2 will be 50. And all I'm doing here is just checking to see that it does make sense and that it does add up to 180. So 60 plus 50 is 100. 60 plus, did I do that right? 70 minus 20 is 50. What do we have? 50 plus... Okay, I think that I've made a mistake somewhere. Let's just quickly go back and have a look. 60 minus 20 gave us 40. 180 minus 40 was 140. X was 70. So it's 70 plus 60. Oh, no. Okay, my adding is just really bad. 70 plus 60 is 130. And 130 plus 50 is 180. Okay. 70 plus 60 is 130. Plus 50 will give me 180. And you can double check that on your calculator. In fact, I would, because I could be lying. All right, but those add up to 180 degrees, which means that your answer makes sense, and therefore x is equal to 70 degrees. But you don't have to show that. Remember, that's just a little way for you to check. If you've got time, especially, then go back and check that your answers make sense. All right, okay. The next question, this one's a little bit more complicated. Now we're going to use the rules that we've learned for congruency. All right. So they give us two triangles, ABC and DCE. And they say determine if the two triangles are congruent. Use the result to find x, angle y, and z. Okay. Remember, with congruency, right in the beginning of the lesson, I showed you that there were 4 different cases that you could use. There was right angle, hypotenuse, side, angle, angle, side, side, angle, side, and side, side, side. All right, so it's one of those 4 that will make these congruent if they are congruent at all. All right, first thing we need to do is examine the two triangles. We see that side AB is equal to 3 and side DE is equal to 3. So that means side AB is equal to side DE. Okay, and guys, you'd notice I haven't started writing anything yet. I'm just examining the diagram and looking at how much of information I can get out of it. We see that angle B is equal to angle D, and they're both equal to 90 degrees. That was given to us. All right, X, the unknown, is a side, Z, the unknown, is a side, and Y is an angle. Now, in triangle DCE, it is possible to work out angle E using angles of a triangle. All right, so remember that's 90 and that's 35, so I can work out angle E by saying 180 minus angle D plus angle C. So 180 minus 90 plus 35. All right, and you can do that on your calculator and you'll get an answer of 55 degrees. So therefore angle E is 55. Okay, so why did I need to do that? That really just shows me that angle E is actually equal to angle A. because we were given that angle A is 55 degrees. So angle E is equal to angle A is equal to 55. Now let's have a look and see if we've got enough information to actually prove that these are congruent. I've got AB is equal to DE, right? So that's a side. We've got angle B is equal to angle D because they're 90 and they gave that to you, so that's an angle. Or some of you might be saying, hang on, maybe that's 90 degrees. Maybe the proof here will be 90 degrees hypotenuse side. Okay, well, we'll have a look and see. We also know that angle E we worked out is 55, which is the same as angle A. So, for those of you who are thinking it's 90 degrees hypotenuse side, or RHS, it actually isn't, because remember, in order for that one to work, yes, we've got a 90 degrees, but you also need to have the hypotenuse of each triangle equal to the hypotenuse of the other triangle. And in this case, we don't know what Z is. And at this stage, we can't find it out yet. Okay, so we can't use 90 degrees hypotenuse side. So how do we prove this? So we set it out by saying in triangle, and the order is important, but we'll look at the order at the end because you need to state the right order of congruency. So let's just say BAC. So in triangle BAC and triangle, so we went BAC, let's look at DEC. Okay, so those are the two triangles I'm looking at. And remember, when you do congruency, you set it out in steps and you start by stating the triangles you're looking at. So the first thing, okay, the first reason for them being congruent is that AB, side AB is equal to DE. And the reason, it was given that they're both equal to 3. So that was really given. They both had a 3 on them. Okay, so AB is equal to DE, that's given. Next thing we know is that angle B is equal to angle D, and that was equal to 90 degrees. And that was also given. They were both, or you could say AB is perpendicular to BC and CD is perpendicular to DE. But really it was also given because they showed you that they were perpendicular. Okay, so angle B is equal to angle D is equal to 90. And then the third thing was the thing that we had to actually work out. So angle A is equal to angle E is equal to 55 degrees. Okay, and remember this angle E, you would have had to first show the working of how we worked out. So we worked this out above. All right. So therefore, they were both equal to 55 degrees, so they were equal to each other. So let's have a look at all of the reasons that we've got here. We've got, just quickly undo that. Okay, so we've got AB equal to DE, that's a side. B is equal to D, that's an angle B is equal to angle D is 90, that's an angle. Angle A is equal to angle E is equal to 55, that's another angle. So therefore, and this is when, I mean, it's really important, your order, as I was saying the whole time, so you should keep that in mind. Therefore, the triangle that we're looking at, triangle BAC, is congruent to DEC. Now, before I actually give the reason here, let's just go and see that this is true, that the sides are in the right order. If I go BAC, look at what I did. I went from the 90 degree across the equal side to this angle 55. So we went BAC. All right, I've got to make the same movements with the second triangle. So I'm going to start from the 90 degree, go across the equal side, and then over the equal angle down to side C. So therefore we get DEC and BAC. So we've got to do it in the corresponding proportion. All right, and our reason here, side, angle, side. And remember, it was important for the angle that we proved to be equal to be between the two equal sides. And well, later on when we show that this is, sorry, my reasoning here is wrong. My final step here, it should actually be angle, angle, side. not side, angle, side. All right, so that, remember your reasoning there was actually angle, angle, side, not side, angle, side. Because if it was side, angle, side, you would need to have your angle between your two equal sides. All right, so now that we've proved that those two are congruent, they say use the result to find x, y, and z. Okay, now x is an unknown side in triangle DCE. Therefore, and we know that angle D is 90 degrees. Therefore, if I wanted to work out side DC, and I know that that's a 90-degree triangle, I can use Pythagoras. So to work out side x, I can say CD squared plus DE squared is equal to CE squared. And the reason for that is Pythagoras. All right, remember we're looking for x, which was side CD, so I can say x squared plus DE, which is 3, is equal to CE, which is 5 squared. So therefore, if I want x squared, I subtract 3 squared from both sides, so I get 5 squared minus 3 squared. So I'm going to get 25 minus 9, which is 16. So if x squared is equal to 16, square rooting both sides, I'd get x is equal to 4. Now remember, whenever you take the square root, it's always plus or minus an answer, but because we're looking at the length of a side, it is impossible for us to have negative 4 units. So therefore, x cannot be negative 4, it has to be positive 4. All right, so we've got the length of x. Next thing we need to find out is the size of angle y. All right, looking in triangle ABC, we can just use the sum of angles of a triangle. Or you can just say, well, if triangle BAC is congruent to DEC, then this angle, y, should be equal to that angle 35, just because they're congruent. Okay, because remember, when triangles are congruent, they're exact replicas of each other. So therefore, this angle y should be 35 because of congruency. Or you can do sum of angles of a triangle. So either congruency, or you can say, work it out using sum of angles of a triangle. All right, so it's 2 different ways you can do it. All right, and then the final thing we need to find here is z. And there we go, there's z there, which is, all right, now this one, let's have a look at this one. This is quite nice because you can't just do it using any other method besides congruency. Okay, so we've got to use the fact that these triangles are congruent in order to find z. Because if you look at triangle ABC, you can't use Pythagoras. You don't have another side. You've just got the one side, 3. So if I want to find z, which is side AC, is going to be equal to the corresponding side in triangle DCE, which is going to be CE. So AC is equal to CE. And the reason for that, guys, comes straight from your congruency. It's because triangle BAC was congruent to triangle DEC. So those two sides are equal, AC and CE. So therefore, Z is going to be the same as side CE. So Z is going to be equal to 5. All right. Okay, so I hope that all of you guys followed that. It was quite a complicated one, and really one of the tougher test type questions that you will get. And I hope that if you've had any problems, you've been posting them to Ty.
Well, so far, people have just been following, like Kosi, I can see he's also been following very closely. Karabo and Lucinda Bouchlier have all been following. So guys, thank you for posting on the page and thanks for showing me that you guys are following. But for now, guys, we're going to see you soon after this break. Welcome back, Mindsetters. I hope you had a nice little break. And guys, you guys have got your notepads and pens out and you guys are making notes because it's so important. And I say it all the time. But guys, don't be afraid to hit us up on the page if you're lost and if you need help. I'm seeing a lot of you guys who are following along, which is awesome. Thank you guys for posting up on the page. And guys, make sure you don't go anywhere and stick around and keep writing those notes because I'm going to hand those straight back to Natasha, who's going to continue the show.
Right. Thanks, Ty. And guys, I hope that you're studying hard. And if you are, then you should have a few questions. And we'll check back with you a little bit later on to see if you do. But anyway, my last one for you for today is quite a tricky one. And I hope that you can follow this. So you need to understand what we're talking about right from the beginning with this diagram, okay? Because if you don't get the first part, you're going to get stuck in the second and then the third, and it's just going to roll into each other. So try to pay attention from the beginning here. Okay, they tell us, they give us a diagram and they say that ABCD is a parallelogram. So obviously all the properties of a parallelogram should come to your head. And in fact, before we even carry on, I'm going to mark those properties down. If ABCD is a parallelogram, we know that AB is parallel to DC, which they've drawn in. BC is parallel to AD. Also AB will be equal to CD. And side BC will be equal to side AD. Okay, that's just from properties of a palm. All right. They also tell you you've got your diagonal AC such that AF is equal to HC. So they've just marked that for you on the diagram. So it's given that AF is equal to HC. The first question says, prove that triangle AFD, okay, so that's this one here. Prove that triangle AFD is congruent to CHB, which is this one on the opposite end. Okay, so the first thing we're going to do is we're just going to analyze those two shapes and see within those shapes if we can mark out some equal things. Because remember, if you want to prove congruency, you need one of those four cases, which means we need equal angles. We see that we have an equal side, but we also need to involve angles and that kind of thing. Okay, so how do we do it? So as I said, before we tackle the question, we're going to mark down a few other things in those two triangles. All right, we already know that HC is equal to AF, that was given, and we also know that AD is equal to BC, and the reason for that is ABCD is a palm. Okay, they gave that to us. All right, now if ABCD is a palm, that means you've got your parallel lines, which is going to give you alternate, corresponding, and co-interior angles. If I look in triangle AFD, angle A1, and I'm just going to use a different color here, angle A1 is going to be equal to angle C1. And the reason for that, if you have a look and follow your parallel lines, you will see that that forms a Z shape. So the Z shape, the type of angles that makes, alternate angles. So we have A1 equaling C1 because of alternate angles. All right, so we've got enough information now to set this out in a proof and show that those two triangles are congruent. All right, and I'm going to try and set this out a bit more neatly for you guys, so sort of give you an idea of how you're supposed to set this out in an exam. So this is question A. All right, we want to prove that triangle AFD is congruent. Remember our first question. Prove that AFD is congruent to CHB. So I'm going to say in triangle AFD and CHB. Those are the two that we're looking at. Let's list what we know, and then we'll see if it has, well, it should have, or it should fulfill one of the reasons for congruency. Okay, so we're looking at AFD and CHB. First thing that was given to us is that AF is equal to HC. Okay, so we set that out with a reason. The reason here is that was given. Okay, AF is equal to HC, that's given. We also know, second thing, AD is equal to BC. And the reason for that, ABCD is a palm, so therefore it's one of the properties of a palm. Since ABCD is, and I'm just going to abbreviate parallelogram to be that symbol there. Okay, but you would generally write that out. So AD is equal to BC because it's a palm. Then the other thing that we showed was that angle A1 was equal to angle C1. And the reason for that was alternate angles. And the sides that were parallel there, AD was parallel to BC. So that gave us those alternate angles. All right, so let's have a look at what we've got. We've got two sides equal, and we've got one angle. Is that angle between the equal sides? Because remember, it sort of looks like side angle side is going to be our reason. But if you want to use side angle side, the angle has to be included between the two equal sides. And in this case, it is. It's between the two equal sides. So therefore, our reason here for these two to be congruent, and we'll say therefore, triangle AFD, and these are in the correct order, is congruent to triangle CHB. The reason there, side, and you can just write it like this, SAS, side, angle, side. All right, so we've done the first part. We've proved that those two are congruent. Now remember, when two triangles are congruent, you get all of these offsetting things, or all of these results. All the corresponding angles will be equal, and all the corresponding sides will be equal. So what that means is if AFD is congruent to CHB, the last remaining side there, which is FD and HB, those are going to be equal to each other. So these two sides, FD and HB, are going to be equal to each other because AFD was congruent to CHB. So that's one of the results from your congruency. Okay. The next question said, and I just want you to keep that in mind because we're going to use that just now. The next question says, prove that DF is parallel to HB. Now remember, if we want to prove that DF is parallel to HB, we need to have our corresponding co-interior or alternate angles. In this case, the one we're going to go for is alternate. We're going to try and prove that F2 is equal to H2. If F2 is equal to H2, then those are alternate angles, therefore DF must be parallel to HB, and that comes from the theory that I showed you right at the top of the lesson. How do we prove that F2 is equal to H2? Okay, and for this one I'm just going to do the working on the actual diagram. So this is part B. We know that from the congruency, angle F1 is equal to angle H1. That's one of the results. Okay, so F1 is equal to H1, and the reason for that was the congruency. AFD was congruent to CHB. Okay, so therefore F1 was equal to H1. So if, let's just say, those two are X. Alright, so we're going to let H1 be X, then F1 is also going to be X because they're equal to each other. So I'm going to say let F1 equal X, and then H1 is also going to be equal to X because obviously they're equal to each other. Then angle F2, alright, and for some reason the pen keeps swapping color, which is interesting. Then angle F2 is going to be equal to 180 minus X, and the reason for that is those are angles on a straight line. Okay, so AFC is a straight line, so therefore F2 is 180 minus X. Similarly, H2 is also 180 minus X because of angles on a straight line, but we've got what we wanted. Because if these two are equal to each other, if those are both 180 minus x, then we can say, but hang on, those are alternate angles, so therefore FD must be parallel to BH. Okay, so F2 is equal to H2, but these are alternate. Okay, so this, you would actually write this out, but these are alternate. Therefore, that means that FD is parallel to HB, which is exactly what they asked us to do. Okay, the last part I'm going to go through very quickly because it really just requires what we've already done. Remember, we've proved from the congruency that HB is equal to FD. It's just one of your results. And now we've just shown that FD is parallel to HB. So therefore, proving the last part, which says prove that DFBH is a parallelogram, is very easy because remember, one of the signs that something is a parallelogram, or one of the proofs, is that one pair of opposite sides is both parallel and equal. That's one way to prove that something's a palm. And we've just shown it. So since, if we write this out quickly, so since DF was parallel to HB, okay, which we proved, and from the congruency, DF was equal to HB, this would mean, therefore, DFBH is a parallelogram, because the reason here is one pair of opposite sides is both parallel and equal. Okay, so in your little brackets you would write there one pair of opposite sides is both parallel and equal. Okay guys, so I think that's it for us for today. We've gone through a whole lot of geometry and we tried to fit everything into one lesson, which is, you know, almost impossible because there's so much to do in grade 10 geometry. But I hope that you guys followed, and we'll cross through to Ty to see if there's any final questions.
Yes, there's actually one that just popped in. Lucinda actually wanted to find out, so many of us, well, she wanted to say, please can I know if I do make a slight mistake, if I misname one of my angles, do I stand a chance to lose marks for that?
Absolutely. If you misname an angle, you will lose marks. So please try and be very, very careful. So guys, good luck with your geometry exam when it comes up. I won't see you again until after you write exams. Cheers from me, and back to Ty.
All right, so guys, this is actually our last session for the semester. So guys, make sure you just keep going on the page and hit up the mindset page. But guys, we'll see you next time, and cheers.